Okay, and so these are our extra examples. Let me find examples I want to do. Shoot. I just want to do different examples, so they're the ones I had are not matching up. To the complexity that I want. Okay. So we will do, oh, not red. Three square root of x plus 2. So that's inside. So we're going to graph this, and we are going to find the domain and range. Okay. So we're going to start with the table. I'm not going to write out all the steps. I'm just going to do the problem how I would expect to see it on homework, how I would do it on the homework. I'm going to use all those steps. I'm just not going to write like 1, make a table. We're just going to make the table. Okay. Now, I'm not going to start at 0. That will not give me the starting point of the graph. We added 2. If you think back to, and this is 3 times the square root. This is not a cube root. This is a square root here. If you think back to our previous unit, unit 1, when we were transforming absolute value or parabolas, this inside here means we go 2 to the left. Right? So my first x value is actually going to be what turns this into 0. That turns that into 0, the inside into 0. So that's my starting value. Okay? Because whatever turns this into 0, that's going to give me the vertex piece. Okay, so -2. And then we just count up from there. So -2, -1, 0, 1, and 2. Okay. Some of these I'm going to be able to evaluate by hand. Some of them I'm going to need a calculator. Does that make sense on why I started at -2? Hopefully. Okay, it's because -2 turns the inside into 0. So when we turn this into 0, we're going to get times 3. 0 times 3, still 0. When we put a -1 into here, I'm just going to work stuff out over here. 3 times the square root of -1 plus 2 is going to give me 3 times 1, which is just 3. So this is 3. This 3 is stretching it vertically, so we're actually going to get kind of large numbers down here. Well, larger numbers. This is going to give me a decimal, and this is going to give me a decimal. This one is not, because it's 3 times the square root of 4, which is 3 times 2, so this is 6. Okay. So these middle pieces here, now we're going to plug those into a calculator to figure that out. Into Desmos. So here is Desmos. That's the old thing we have. Don't really need this. We just need to figure out 3 square root. Whoa. 3 square root 2. And so we get 4.24. And then 3 square root 3, 5.19. Okay, so our table, after a calculator, looks like this. Looks like this. Okay, so then I'm going to graph those points. -2, 0. -1, 3. This graph is going to get tall, taller than the other ones. 2, 6. So 1, 2, 1, 2, 1, 2, 3, 4, 5, 6. And then these other points are going to be in here, right? 4.25, 5.2. So it's going to look like that. Okay. And then the domain and range, this has been stretched vertically from the original, and it got shifted 2 to the left. You can think of these in transformations when you're graphing, but you can also just use the table. Right? Okay, and then what's the domain and range? Well, the domain is x is bigger than this value. X is greater than or equal to -2. And the y values are 0 and up, the range. Y is greater than or equal to 0. You'll notice these two numbers match this coordinate point. Right? Because this is the coordinate point where we're starting at. So it's going to be to the right of here or to the left if the graph was flipped over. And it's going to be up or down if the graph was flipped over. And then we're done. So we graphed it, we made our table, and then we have the domain and range. Okay. We got time for like one more example. That's perfect. So we're going to do a cube root function. We'll do this one. X minus 1. So this is inside the cube root. And then outside the cube root, we're going to add 3. Okay, so we're going to make a table just the same. And this does not start at 0. So normally we'd put 0 in the middle here. But in the same way as the last one, what number turns this into 0? That's going to be our middle point. It's actually 1. Right, so then I'm going to go 2 down. So 0, -1, and I'm going to go 2 up. So 2, 3. Putting a 1 into here turns this into 0. It's like the vertex. This is like the vertex from when we were doing square functions or absolute value functions. We've gone 1 to the right and then 3 up. Okay. So then some of these numbers are going to simplify really easily for the cube root, and some of them are not. So when we put 1 in here, we get 0 plus 3, so this is going to be a 3. If I put 2 in here, get the cube root of 2 minus 1 plus 3. So the cube root of 1 plus 3 is 1 plus 3. So this is 4. This is 2 because it's the other way. You get a -1. And then it's -1 plus 3. And then these two are going to be decimals. So I'm going to plug those into Desmos. You could plug all of these into Desmos, right? So here's Desmos. We need a cubic function, so this isn't going to work. And it's going to be -1 -1 plus 3, so 1.74. And then if we put a 3 here, it's 4.25. Now, I said before that it was symmetrical, and it is symmetrical. It's the values that don't look symmetrical. Where did I get the 3 from? Which 3, Daniel? You're talking about this 3 right here? Or like this 3? Or are you talking about? Yeah. So this is just the part of the problem. This is what was given in the problem. And so we have some stuff in the cube root, and then this plus 3 on the end that is just getting added. If you remember back to our functions for square roots, we had y equals a times x minus h squared plus k. This is the exact same, except instead of a square here, 2, it's a 1/3, which gives us the cube root. Right? So we have our minus h, we have our plus k here. We're multiplying by 1. There's sometimes we multiply the x on the inside by a number. So yeah, it's the same form here. It's just instead of a square function, it's a cube root function. Yeah. So then we graph those. So 0, 2, 1, 3, 2, 4, 3, 4.1, 2, 3, 4, 4.25 is like here-ish. I don't know. And then -1, 1.74 is like here. And so our graph goes like this. And this point is the center. Not the best curve, but close. Close enough. Okay, and then the domain and range, because it's cube root, domain is all reals. And the range, also all reals. And we're done. So we made our table, we graphed it, all reals. Use a calculator for this, right? We're getting decimals here. You're not going to be able to figure out the cube root of 2. I don't know the cube root of 2. There are ways to figure that out, but yeah. All right. So we have like 7 minutes left. I'll do another example. So let me find one. Let me find one with multiplication on the inside, because sometimes that happens too. This thing, multiplication on the inside. You might not get a lot of those. Maybe we, oh, here's one. Yeah. So we're graphing y equals negative the cube root of 4x. Okay. This one's going to 0 in the same places. So our table, and I know we have like 5 minutes left. Our table is going to be the same. -2, -1, 0, 1, and 2. Okay. These are all, well, 0 will give a whole number and then the 2's will, but the 1's will not because we're going to get a cube root of 4. So for 0, it's just 0 again. For 2, you get 8, so it's the cube root of 8, negative cube root of 8. So this is -2, and this one's going to be +2. Because you get -8 in here, and so you get negative, and so you get cube root of 8 is 2. That's where these are from. So, but if you put in -1, you're going to get the negative cube root of 4. Right? And so this we need to use a calculator for. And so using a calculator, we get negative cube root of 4 is negative 1.58. And so this one's going to be positive 1.58. Okay. And then we just graph those points. So we get 0, 0, 1 comma negative almost 1.5, so about here, about here, and then 2 comma -2, and -2 comma +2. And so our graph looks like this. It's flipped around the x-axis. It's been flipped around, so it's pointing the opposite direction. That's because there's this negative out front. Or maybe it flipped it vertically. I don't remember which is which. But it didn't shift left or right at all. It's just been flipped over. And then our domain and range are the same. So the domain is all reals, and the range is also all reals. This doesn't describe where you're going to find the numbers. So like if you plug in 18, what kind of output will you get? That doesn't tell you this at all. This doesn't tell you that at all. It just tells you if I put in, what can I put in and what could I possibly get out? Okay. And so that's graphing. Some more examples for graphing radical functions.